Okay, so I'm going to do a problem at a time. Get the colic down here coming out of cold with a hat. Boy, oh boy, starting to look like alfalfa again, except alfalfa didn't have a beard. All right, he was about 9 years old, so I take it all back. Last test, midterm, a lot of trouble with finding the max of or min, I forget what it was, of a cubic, the local max, local min. Boy, did that throw a lot of people. So as your instructor, I see that and I go, I should have covered that more. So we'll start off with that right now, and perhaps we'll throw the first problem of every worksheet your way when you get back with a little max min challenge. So right now we're going to go to Texas. Whoopee! Okay, we got a related rates on the other side. I'll make the next video on that, but right now we're up there. All right, and that's the Rio Grande. So put your hat on. All right, and we're going to get some steers and we're going to put them in a rectangular pen, and we want to maximize the pasture area. Yeah, get those lassos out. Unfortunately, we're not in Texas because New England right now is about 5 below wind chill factor outside, and it's going to be about 15 below tonight. So we're not going to get too many steers. All right, and unfortunately, they're not going to in Texas much longer either because they're having trouble growing grass because of drought. Over the years, a lot of ranches closing. Hopefully we can solve that going forward. I'm going to solve this by maximizing my screen. That took a button. It's going to take some calculus. All righty, so what do we got? 200 feet of fence, and we want a rectangular pen. So let's start off with the fact that I hope you did these word problems in Algebra 1 and probably maybe Algebra 2 and solved them there. We're going to use a little calculus. Right, so we know we got 2 x's. Then we got to add some amount of fencing to get to 200 feet. And so therefore we know that this is 200 minus 2x, cut to the chase. All right. So area in this case is equal to minus 2x squared plus 200x. Well, that's good. You can do it without calculus. It's just parabola. We know that, yeah. But when you're trying to find maxes and mins, a lot of times you don't know what the shape is. Sure, it would be nice if it was concave down. The slope is 0. That proves it's a local max or absolute max. We'll be studying those too. No big deal. Concave up, slope is 0. You got a min, and we know how to find concavity. First derivative is decreasing or increasing. Tells us concavity. So does the second derivative, positive or negative. It seems like there's a connection there between the second and first derivative. The rate of the first derivative is increasing. Second derivative positive. Yeah. Anyway, so let's find the slopes of 0 first. So we take rate of change of area is equal to minus 4x dx. This is the geometric change of that layering process. It's got the dx here, doing that right now, plus 200 dx. And then if we want to look at a little change in x and how it changes the area, I guess we got to divide by dx. And so now we have a, kind of a dy dx where y is the area, right? So we got ourselves a derivative, minus 4x plus 200. We set it to 0. Yay! X equals 50. Okay, so we now know, but we haven't proved yet that that's the shape. One way is to look at the tangents. That tangent at 50. I know that tangent has a slope of 0. I wonder what the tangent after it has. It doesn't look like 0 anymore. It looks like a negative. What about the one before it? No, the tangent's a positive. Why don't we make ourselves a little box chart here? There's only one critical number, 50, right? Let's put a number bigger than 50 in. Oh, that's negative. Let's put a 0 in. That's less than 50. Oh, that's positive. Geez, I think I got this picture. I think I just proved. Yeah, I think I just proved. Like a box chart like that or whatever they're called. I like graphs. I like the graph minus 4x plus 200 because then I can more quickly see positive to negative. Grandma's velocity is positive. She's going north. Negative, she's heading south. We're getting better at that. Real pleased with a lot of the midterms. Yeah. So that's one way. The other way is to prove that it's concave down. Well, that's the second derivative, right? That's second derivative with respect to x, which is this notation. Oh, that's minus 4. I got a feeling this graph is always concave down. I don't care what X you put in. Oh, concave down shape, slope is 0. We proved again, we have a max. Done. Video over. Back to Texas. Sitting down. Gonna have me. What do you have in Texas? I don't know. I would like to say ribs or something, but I'm trying to be a vegetarian.